When we wrote functions, we saw two keywords, peer and view. What's the difference? Both the keyword peer and view indicates that the function is read-only. It's not going to write anything to the blockchain. The difference between peer and view functions is that peer functions do not read any state or global variables. On the other hand, view functions are also read-only, but they can still read states and global variables. So, for example, let's say that we have a peer function. I'll make this external and make it peer. Let's call this function add, takes in two inputs, uint 256 and y uint 256, and it will return uint 256 and say return x plus y. Why is this function a peer function? Well, because it does not read any state or global variables. And also, it is read-only. And what would a function that is not read-only look like? For example, let's say that we have a state variable. Let's call this count public uint 256. So we have a state variable called count. And if we were to update this state variable by saying self.count plus equals 1, then now this function is not read-only. It's trying to make an update to the state variable count, so this will not be read-only. So that's what it means for a function to be read-only. How about what does it mean for the function to not read any state or global variables? Currently, this function does not read any state variables, so it is pure. However, if we were to say something like x plus y plus self.count, now it is reading from a state variable, so this function will no longer become pure, since it's reading from a state. And the other part, global variables. For example, let's say block.timestamp. Now it's reading a global variable called block.timestamp, so again, this function will no longer be pure. Okay, in contrast, let's take a look at example of a view function. Again, remember that the view functions allow us to read state variables and global variables. Say external, and say view, def, let's call this add to count, x uint 256, and it will return uint 256. And then let's say return x plus self.count. Here it is taking the input x and then adding it to the current value of the count state variable, which is declared over here. This function is still read-only since we're not making any updates. However, this function is not a pure function since it's reading a value from a state variable. We can also read from a global variable by, let's say, block.timestamp. Okay, let's try compiling this contract. Okay, the contract compiled. Let's try deploying it. And then call the function add 2 and 3, get a 5. And then if we add to count, let's say 1, what you're gonna get is a big number since we're adding 1 with the current value of the state variable count, which is equal to 0, with the current timestamp.